And welcome everyone to Learn a Trade Training Membership Program. Glad to be here with you all today. Today's lesson is Module 8 on the FBD Frozen Beverage Dispenser Model 56 series. Today we'll be going over the troubleshooting of the upper power board, and also we're going to get into the lower power board today too. So let us begin. Troubleshooting the upper power board, the UPB. All LED lights on upper board should be solid green under normal operation. Dim or off LED lights. If you have dim or off LED lights on the board, you'll see those LED lights up top here. You should first check each test point and verify tolerances are within 5% of plus 15, minus 15, and 5 volts DC. On an old board, DC 16 blinks when 5 volts is present. New board doesn't have indication lights. If 5 volts is not present, check harness for continuity and verify the lower power board DC test points. Replace harness if harness is bad. Replace upper board if harness and the lower power board are good. Test points for your upper board. We're going to start up here with test point 1, TP1. TP1 is your 5 volts DC, positive 5 volts DC for relay board coils, comes from lower power board. Test point 2, positive 5 volts DC for logic power supply, comes from lower power board. TP3 is a plus 15 volts DC analog voltage for temperature and pressure sensor readouts. TP5 is a negative 15 volts DC for your analog voltage for temperature and pressure sensor readouts. TP6 is plus 5 volts DC for microprocessor or EEPROM. TP7 is your ground. TP7 is your ground right here. You see it right there. TP8 is your ground A. That's right here, just below the TP7. TP7 is your ground D. TP8 is your ground A. TP9 plus 5.12 for a microprocessor. That's right here. That's your test point. TP10 positive 5.12 for pressure sensors. That's for your pressure sensors. So those are all of your test points on this upper board. EPS EEPROM replacement. This is your EEPROM chip, which, let me go back and show you. That's your EEPROM chip. That's where it goes on the upper board. And this is what your EEPROM chip looks like. And this right here is your EEPROM removal tool. Some technicians may not have this tool, and in that case, they would usually use a small screwdriver to kind of pull out that EEPROM chip. If you're in a position where you're getting on-the-job training, you would probably be given this by your employer, or you could also order it through Parts Town or something like that. But let's go with step one. Step one in your EEPROM chip replacement is record machine settings, such as your voltage offset, your defrost times, and your wake up sleep times. Now, this is something that you would record. You would just write it down. You'd write down what the original voltage offset is with the old chip still in, and you can get all of this on your readouts. Okay, this is where you would go into the service menu, then go to readouts. You could go to common, and then you would be able to see your voltage offsets, your defrost times. You can go through the menu to get your defrost times and your wake up and sleep times, if there's any stored. Most cases, like I said before, these locations are usually 24/7, so they usually have no wake up or sleep times set for those. Next, you would disconnect power to the machine, remove the old EEPROM chip with chip puller. That's with this tool right here. Install the new EEPROM chip with the notch up. The notch is right here. This little notch right there up top. That's going to be facing up always. Reconnect power to the machine. Wait 1 minute for software to load. Next, you would scroll to load all defaults to reset. And this is a case where you would go to the end of that service menu and you would load all defaults, because you have a new chip in place right now and you want to reset that to the original setting, and then that's going to set the machine to the original setting, and then that's going to allow you to re-enter your recorded values that you recorded from step number 1 up here. So you're going to re-enter your voltage offset, your defrost times, and your wake and sleep if you had any. And then next you would press off, defrost, then run for each barrel. And then each barrel will go ahead and go through a defrost cycle, and then it will run, go into a freeze cycle, and all barrels should freeze down, and your settings are already loaded. Next, we're going to troubleshooting the lower power board. This will be your lower power board. All test lights on the lower power board should be solid green under normal operation. So all of the test lights should be solid green, okay? If any LEDs are dimmed or absent on the lower power board, disconnect P13 and P14 from the lower power board to gain access to the test points. Use ground, TP4 ground, to check voltage at test points. So you're going to go to the TP4 position on the board as your ground. You're going to use that as your ground, and then you will be able to go and test all of your test points if you needed to, if you didn't have any LEDs that were on, or if you had LEDs that were out. This will enable you to find out what functions are not working. If voltage is not present, test voltage at TP8 for 24 volts DC. AC. You would test point 8 for 24 volts AC, and test point 18 for 12 volts AC, which come from the transformer. This is your TP18, and this is your TP8 test points right here. This is where you would test those out at. If voltage is present, replace the lower power board. If voltage is not present, replace the transformer. So if you test those points and you have no power, you would then replace the transformer. There's an issue with the transformer. And that's that small transformer that sits down below, and the lower power board is right to the right-hand side of that transformer. Troubleshooting. Condenser fan. During defrost, fan does not normally operate, but there are some units that have the option to turn it on during defrost. The fan will only turn on manually. The fan will only turn on manually. If the compressor is turned on, the fan should come on. Next, you want to disconnect the wire harness from P12 on the lower power board and inspect the connection for separated pins or broken wire harness. Replace wire harness if needed. So this will be your fan connection, and you would want to test those points, and if you did not have power there, then you know that there's an issue. Using a voltmeter to test connections on your lower board at P12, measure across L1 pin and P12 connector. This is your L1 pin, and this is your P1 connector. Okay, this is your ground, and then this is your L2. So you would check across these two pins. Voltage will range from 85 volts AC to 125 volts AC. If voltage is present, manually turn on the condenser fan using the manual on and off that's in your service menu. Test for voltage across L1 and L2 pins from P12 connector. So this one you're going to test across L1 and L2. The voltage range from 208 to 230 volts AC, depending on the incoming voltage. If voltage is not present, replace the lower board. So if you do not have power there, then you want to replace the board. If voltage is present, inspect the wire harness for condenser, fan, motor. If condenser fan harness checks out good, problem could be within the fan or capacitor. So if everything else tests good, your voltage is present, and you inspect the wires and the wires all seem good, you could have an issue with the fan itself. The fan shaft, the motor shaft could be bound, or you could have an issue with the fan capacitor, in which you could just change out the capacitor, and then that would enable the fan to work. Next, we're going to go to initial startup and freeze. Validate the setups matches 56 series setup requirements. Perform visual inspection for leaks. Load all defaults. Fill barrel with CO2 until tank pressure reaches to 10 psig. Then purge barrel until tank pressure is at 0 psig. Repeat this process for 3 times to empty out the air. Press the fill button and beater button to fill the barrel. Fill barrel to just below the relief valve. Note, in the filling process, motor will need to be stopped to check filling level, and relief vent valve will be pulled to allow filling. On some of the other videos, I've shown that you have to pull that little vent valve from time to time when filling the barrel. That's all that is saying. Then the next step is press the off, the defrost, and then the run button. Verify and or update the time, date, daylight savings time where applicable, wake up sleep time, and defrost time. So you're just going through the readouts to verify. You're going through the service menu to verify your date and your time, make sure everything's in there correct. Make sure that your wake up and sleep is not set for certain times or anything like that. If it's a 24-hour location, if it's a private location and they have wake up times, you want to make sure you have the correct time set. And then after freeze down, pour several 12-ounce cups to check product quality. So on this part here, you would then take a cup and dispense some product into the cup to make sure that the quality looks good of the product. Let's go over the status lights. You have the sold out light, which is indicated to the customer that do not use when lit. So when this is lit, the customer can see it, and that's telling them that it's not ready to be used yet. This is your annunciator pad, and it'll have product out, and it'll have a red light there if the product's out. If it's in defrost mode, this light will be on. Ready to serve, that light will be on. Not ready, this light will be on. And then this is just a chart telling you about the different light actions of the light. So if you have a red light flashing any single barrel on any of the barrels, it could be one of these, either product out or not ready. Lights flashing on any single barrel. That means the cause is that it's out of syrup for that barrel. Your LCD, your screen will say syrup out for that particular barrel. And then the solution is to simply replace the empty syrup bib container. All red lights flashing, all the barrels, that could be one of these light statuses will be on. These lights will be flashing again. The cause could be out of CO2, could be out of water. And you would have that displayed up here in the display screen. It'll say either syrup out or H2O out, or you might even see some where it says both. And in that case, something happened where the main CO2 or the main water has been shut off. And a lot of times you'll find on the bulk tanks in the back room that someone may have hit the CO2 shut off valve and turned it off and not realized it. So that could be an easy fix for you. Then the solution is to replace the empty CO2 tank or check the water supply if it's out of water. Next, we go to red light continuously on any barrel. These lights will also be flashing again. And you notice anytime that there's something wrong, mainly your product out or your not ready lights will be flashing. So the not ready light, that'll be flashing also. And that could mean the cause of the unit defrosting, is in defrost mode. And the solution to that is, if on defrost during peak draw, cancel defrost by pushing defrost, and then that'll shut the defrost off, and then push run, and then that'll allow it to run again. And then the not ready light, if that's on, the unit is in its first freeze after a defrost. So it could just be starting to freeze after it went through a defrost cycle. And if there's no message on the display, during this time, it'll only say freezing or not ready yet. And the solution to that is to wait until the unit completes the defrost and freeze down cycle. And then next, no lights and the unit is not running. No lights and the unit is not running. The cause could be the unit is not plugged in or the breaker has tripped. There's no message on the screen. The solution would be to plug in the unit and reset the breaker, then restart the unit to see if this issue continues. And here is a list of some of the LCD messages that you will see on the FBD units. The first one you're going to see commonly is hot product shutdown. The meaning to this is the compressor was on with both temp sensors are at 90 degrees or below -20 degrees. So the sensors could be reading wrong for an amount of 3 minutes and 20 seconds. If a sensor senses one of these temperature levels, it's going to go into a hot product shutdown. And then in that case, you would have to go into the readouts and test out your sensors and to see if any of them are at 97 degrees. If it's something like that, when a sensor's at 97 degrees, it's bad and you'll need to change it out. Next is compressor ran too long. Off. Compressor on for longer than 90 minutes. Defrost Pro / Run Pro, product out condition for more than 15 minutes. So if the unit runs without any product connected for longer than 15 minutes, this message will come up. Stop beater, long product out. There's no meaning for that. The run Pmax, that's your tank pressure at 55 psi for more than 15 minutes. Your stop beater, long Pmax, stop motor due to long Pmax. So the motor stopped because this Pmax error was up. Next is your in temp error. That's an error. You have a failed inlet temperature sensor. And next you would have R temp error. That R temp error is you have a failed return temperature sensor. Your tank PSI error is during filling tank pressure, transducer stays at 0 psi for 30 seconds. Your S file R errors, you don't see those often, but they do come up. This is during the fill Tank pressure, transducer stays below refill value for 1 minute. You don't see that an awful lot though. Next one is beater low. That's a common one. That's when your beater drops below 200 or 300 psi and triggers a defrost cycle. The beater high is the beater is above 1200 psi. CO2 out, CO2 pressure is below 35 psi. H2O out, water pressure is below 35 psi. Syrup out, syrup pressure is below 35 psi. Defrost, machine is in defrost mode. Sleep means machine is in sleep mode. Wait, meaning the machine is in first freeze process. Ready, machine is ready in ready mode. Run off, machine is in off mode. Compressor run, compressor is on. And we're continuing on with LCD messages. These are all the messages that you will see on a FBD. Defrost beater means the defrost mode from the machine is off. Defrost wait, defrost is in waiting mode. Defrost, machine is in defrost mode. Defrost suspend, defrost suspended due to freezing of other barrels. Defrost pro, out of product condition during defrost. Fill H, tank pressure in above full pressure in filling mode. Run beater, freeze mode from machine off mode. Run hot gas valve, freezing mode from machine off, mode while another barrel is waiting to defrost. So each barrel is in could go into a defrost mode, and if there is other barrels that are freezing down at the same time, then that barrel that has to defrost is going to go into this mode, defrost wait. It's going to, or run wait, okay? Run CWT is waiting for compressor turn on from the machine off mode. Run freeze, commanding freeze down cycle in the machine ready mode. Run FWT, running freeze down cycle in the machine ready mode. Run thaw, machine is in thaw state but in ready mode. Run THW, transition from run thaw to run freeze. Pressure max, tank pressure is above 50 psi. Run pro, product out in the freeze down process. Filling, machine in filling mode. Has not satisfied the full pressure value. Fill H, tank pressure is above full value. Product OT, CO2, water, or syrup out in filling process. Product OT, CO2, water, or syrup out in filling process for more than 15 minutes. F pause, pause routine in filling process. L fill, tank pressure below refill pressure in first freeze process. L fill H, tank pressure is above full pressure in first freeze process. Some preventive maintenance steps. Manually activate CO2 solenoids to assist emptying barrels. That's where you would go into your menu, go over to manual on off, and you would turn on whichever barrel you're wanting to drain. You would turn that barrel's CO2 valve on and then proceed to drain the barrel. Next, deactivate all CO2 solenoids and depressurize barrels. Perform visual inspections for leaks. Replace rear seals per PM recommendation, and repair DDV valve as needed. Sanitize unit following recommended procedures. Clean air filters. Follow initial startup and freeze procedure to start machine. So that rear seal they were talking about, you can see they have a pick here. You would use a pick, and that is in the rear of the barrel. So you would have to reach your arm in there with the pick, and then you'll dig your pick into the rubber material of the seal, and then you should be able to get enough of the pick in there to pull that seal out of the barrel, and then you'll replace it with a new rubber seal. And then they recommend replacement of these seals every 6 months. Approximate PM time to finish a PM on a 564 is an hour and a half that they have it rated for. That can be disputed, because that could be, it can take 2 to 3 hours if the unit hasn't been PM'd in the past, and you're doing the job as according to their recommendations. It could take longer than an hour and a half, but that's their recommendation. Your PM parts needed are rear seals and Dow 111, the lubrication. And then down here, they have a maintenance schedule. They have a daily maintenance schedule, and a quarterly and a yearly. And that'll do it for this lesson. I thank you all for watching. I hope this is useful to you. I hope you were able to get some good notes. There was a lot of information here. So please, save these videos so that you can go back to them and take down the information that you need. And as you can see, I had scrolling across the screen today. Thank you for your membership. You all are valued members of Learn a Trade, and we appreciate that. And if you can, feel free to drop us a line on your progress at the email listed below. So that's all we have for this module. We will see you next time on Learn a Trade training with module 9, and we'll get started with remote condensers. Thank you very much. Take care.